Hi, everyone, and welcome to Grafana. I'm Brian Summers, VP of Products at Apeel. And welcome to our session on how Apeel Sciences uses Grafana to optimize our treatment processes. First, a little bit about me. I've spent the last 20 years building data-intensive SaaS solutions for enterprise companies. I joined Apeel about 18 months ago to help launch digital data solutions that support Apeel's mission. Apeel Sciences is in Santa Barbara. It's an ag tech company, and its mission is to reduce food waste and create abundance for all. Today, Apeel has a coding solution, which I'll discuss in more detail in a minute before handing the mic over to my colleague, Bailey Hyatt. Bailey is a software engineer on our team responsible for implementing and maintaining Grafana at Apeel. Bailey and I support the teams responsible for delivering treated fruit with software and data solutions needed to manage and optimize our operations. We also work on future product solutions that will inform food supply chain participants on causes of food waste so they can be resolved, further supporting our mission of reducing food waste while also saving our customers money and increasing their profits along the way. So today, Bailey and I will discuss how we use Grafana behind the scenes to remotely monitor and optimize our own treatment processes and alert stakeholders when something goes wrong. So here's the agenda. So first I'll provide an overview of Apeel's mission and solution. And then I'll dive into Apeel's treatment system architecture and how Grafana fits in. And then I'll hand it over to Bailey, who will dive into specific Grafana dashboard use cases and our future roadmap. So why is Apeel on a mission to reduce food waste? Well, it turns out food waste is a huge problem for all of us. The total cost of food loss and wasted globally amounts to 2.6 trillion annually. And almost half of this, of our fruits and vegetables that are grown don't make it to people's mouths. And this contributes 8% of greenhouse gas emissions. Food waste is not only going to become a bigger issue over time as well, since we'll need to grow 56% more food by 2050 just to continue feeding our growing global population. This on top of the fact that our food system is already pushing the limits of what the earth can sustainably support today. So this makes our current practices and food system unsustainable. It's absolutely imperative that we eliminate food waste so that we can feed our current and future global populations. So how does Apeel work? So all fruits and vegetables contain Apeel, which protects them by keeping moisture in and oxygen out. Apeel reduces food waste through a coating solution. So Apeel extends the fruit and vegetables protection with a plant-derived coating. So our coating is made from the same materials found in every bite of fruit and vegetable that you eat every day. And this edible peel applied to the outside surface of fresh produce reinforces the peel and slows down spoilage. So by staying fresh and delicious for up to 2 times longer, Apeel protected produce helps prevent waste, which in turn conserves precious resources like water and avoids greenhouse gas emissions to help mitigate climate change. So by extending the shelf life, Apeel gives all supply chain participants more time to deliver produce from farm through pack house and distributors, through stores and restaurants, and finally to shoppers and consumers. So this reliably means that all nodes in the supply chain can reap the benefits of more time. So for example, growers can actually leave their fruits on the tree longer so that they ripen and they're tastier. Distributors can use this time to bring produce to new markets that are further away and also modify their modes of transportation, which can decrease carbon emissions. Grocery stores have more time for shoppers to purchase produce before they throw it away. And consumers have more time to enjoy what they bought on their counters and fridges. So where before waste became a tax that impacted everybody, Apeel now creates a savings account of time that can be accessed by each node that needs it, depending on the product or the supply chain. So we measured our impact on food waste and water usage and carbon emissions. And in partnership with our suppliers, retailers, and consumers, we've been able to make a big impact on waste. So from January 2019 until June 2021, Apeel helped save 42 million pieces of fruit, which in turn avoided 10,000 metric tons of carbon dioxide emissions and 4.7 billion liters of water. All right, so due to the nature of our business, Apeel has to operate where produce is grown and packaged. So today, Apeel has coating operations in 7 countries around the world. And this is where we coat lemons, oranges, grapefruit, avocados, limes, apples, and English cucumbers. So having operations spread out across the world is necessary, but also presents us with many operational challenges. And as you will see, Grafana is instrumental in helping us overcome some of these challenges. All right, so I'm going to dive into our system architecture here. And you can see our system architecture has been designed to support our distributed operations. So in all the pack houses around the world, data is collected through a combination of operators and machines. And this is illustrated at the bottom of the slide. All this data is collected so that we can monitor and optimize our processes. So treatment measurement data that is collected from various sensors is first sent to a PLC, a programmable logic controller that controls the equipment. And it then sends this data to a server that is located at each site that we call a streaming hub. The streaming hub organizes this data and sends it up to our data lake in the cloud, where the measurement data is stored in a relational database. The streaming hub also provides data storage redundancy in case there is an interruption in the internet service, which occurs more often than we would like since we are operating in remote locations, which often don't have reliable internet service. From our data lake, we are able to serve up real-time dashboards in Grafana to visualize, monitor, and alert stakeholders on the treatment process that are being conducted around the world. So supervisors and managers who might not be on site all the time now have visibility into what's going on there. So Grafana is deployed in our cloud infrastructure. And Grafana is also integrated with our single sign-on identity management solution so that all employees can have a seamless login experience. We were very pleasantly surprised to learn that Grafana not only supports single sign-on, but can also still allow external users in who aren't managed by our corporate single sign-on solution. Since we have some external parties who also want to gain access to our data in these partner facilities to help us manage the treatment process. So Grafana allows us to grant them access in a secure and controlled manner, so they are only provisioned the data that they should see and not all the data which is proprietary. So in addition to the real-time monitoring use case, which are supported by Grafana, we also have our enterprise reporting solution, which is used to report on historical data. So we bring aggregated treatment data from the data warehouse in there so that we can merge these data sets with other enterprise data for reporting and analytics. So today we don't send operator generated data to Grafana, but in the future we are exploring how we can use Grafana to collect this data from the Grafana interface instead of other systems that we've had to build custom, which will make it easier for the operator and easier for us to support and also manage that data set together in a more comprehensive way. And so Bailey is going to dive in deeper on that and other use cases.
Thank you, Brian, for that awesome introduction. So just to pick up where he left off, with our streaming data, we're collecting all this awesome data from these sensors and PLCs inside these packing houses around the world. And so at each of these packing houses, the sensors, they're pushing data into our streaming hubs, and our streaming hubs have local databases that are isolated. So each packing house only has their own data. And then when there's access to internet, the data is uploaded into our data lake, as Brian described, and it is pulled right into Grafana in real time, which is awesome. And so this is what makes Grafana so great is, let's say we have a new packing house in a new country. Once the streaming hub is configured, the data already automatically gets into Grafana. There's no other configuration that needs to happen because Grafana is directly connected to our data lake. And so we can start factory acceptance testing and making sure that everything is configured correctly. And in the past, we've caught variable scaling errors, problems with the device's programming, and just overall have been able to gain a rapid understanding of the device and how it's all functioning, just because we're able to see this in our dashboards. And so just before I jump into our actual dashboards, I want to show you what sample data might look like. So this is what our cloud database resembles. All of our localized data has been pushed up into the cloud, and we have these different location IDs that are identifying the different packing houses, but it's all in one database. So we only have to source from one database to display in our dashboard. And so at each row represents a location ID and a recorded date time. And then we have a JSON value with all of our measurement data that might be measuring energy level or water usage or temperature. And this array works for flexible configuration on the sensor end. So, we have all this different type of sensor data, but it can all go in the same schema. And I just wanted to emphasize that having Grafana is so useful for our non-technical users because, instead of just having to pull a CSV that looks something like that, we're able to display all our data beautifully and in real time. And so it just makes everything that much more accessible. So now I'm going to jump into our use cases. So currently in our packing houses, our field specialists, they're walking through machinery a few times a day throughout our packing house to check on equipment, make sure it's working properly. And so if we have all these different PLCs and sensors, the field specialists, they are actually walking up to the equipment, reading the numbers that are coming off of these sensors, and then recording into a Google Sheet. And so that creates a couple problems. One, it's time consuming and it requires staff on site at all times. Two, it's possible that the equipment might spike or temporarily malfunction at a time that a field specialist is not standing there reading the numbers. Let's say that our sprayer stops spraying and they're not seeing that at the time, they're not on their quality walk. We're not able to pick that up. But with Grafana, we're going to be able to see that. And then also, we're just losing precious data that can be used for further analysis and just continue to round out our understanding of the supply chain. And so all this rich data, we want to be able to use that. And so that's where Grafana has come in. So I'm going to walk through 4 different use cases or just ways that we're using Grafana. So the first being, how can we automate our equipment readings? A lot of what I just introduced. How could we be alerted of our equipment being out of spec while our field specialists and engineers are working remotely? Third, I'm going to walk us through a demonstration of throughput and how we can use variables to create more flexible and scalable dashboards. And then lastly, I'm just going to introduce how we integrated our single sign-on. So first with automating equipment readings. So as I just said, a field specialist might have to walk around a facility for up to 30 minutes to take all of these measurements. But with this dashboard right here, we're able to see all of these different measurements in one place. And it doesn't even have to be on site. I can access this from across the world and see all this bright and rich data. And so what happens to simulate a quality walk is a field specialist will select a certain time range. This is usually this represents a bin dump. So a bin of fruit being dumped onto the conveyor belt to be treated. And so using the time select, they select a window of time, and then it zooms into this super granular 2-minute time scale. And we're able to collect all this data, like how much fruit is coming down the line, or what's our average humidity, or our average fruit temperature. And these are all pulling from different sensors and from different tables. And yet it's all right here in one place. And then lastly, even with qualitative data, this is just a text type panel, but we've actually used a variable to configure the fruit type and then put it right into the HTML, and then it'll change based on whatever type of fruit is being treated, which is awesome. And so, yeah, that is how we're going to be able to save the field specialists a ton of time and having all of the data right there. And so, yeah, that is step one. So what we can do to build on top of that is we can start to build alerts so that we can see if our equipment is ever out of spec in real time. So I'll just walk through our first way that we're starting to use alerts in the field. So let's say we're tracking our fruit surface temperature. What happens with Grafana alerting is we create a query. So for us, we're going to be looking at the past hour of data. And if that most recent time point is below spec or in the red zone or just out of what's in our acceptable values, it'll go into this pending state. And then we'll continue it to evaluate for about 30 seconds. And if it's still in the red zone, then it'll fire the alert and it'll stay firing until it resolves and is back in that range of acceptable values. But realistically, someone's not going to be watching this dashboard at all times. So what we've done is we've integrated into Slack. And so every time an alert fires, we'll get a notification on our Slack that something's out of spec, and the field specialists and engineers, they'll be able to go into Grafana and they'll see exactly when the equipment started malfunctioning. And let's say down the line, we have a bad batch of fruit or something happens, we can now go back to this time frame and we can say, oh, well, that's because this equipment wasn't working in this. Like, we're now able to have a better understanding of what's going on. And so that's really, really awesome. And the third use case that I'm going to go through is a demonstration of how we are displaying our throughput. And so what is throughput for those who don't know? Throughput is the number of items passing through a system or a process within a certain period of time. And so for the context of Apeel, we're trying to track how many avocados are coming down the line within a certain period of time. So let's get into the demonstration. I wanted to give a brief demonstration on our throughput and how we're actually visualizing that in Grafana. And so as I stated, throughput is how many items are coming down our line. So how many avocados or another type of fruit are coming down the line over a given time period. And so essentially what this graph is showing, and I'm going to go more into detail with the data in a second, but essentially what this graph is showing is at any given second, let's take this, it's counting over the past 300 seconds. And so what the user will do is they will select, okay, how what's the interval that I want to calculate the throughput over? So I have it set to 300 seconds. So over the past 300 seconds or 5 minutes, what is the average amount of avocados coming in through the line over 1 second? And so now we can track that across time. So across time, how many fruit is coming down on a second, and we're calculating that over a 5-minute interval. But what's awesome about this is we've created this variable where users are able to change the granularity of what we're calculating over. And so let's change this to 45 seconds. Now we're saying, okay, over the last 45 seconds, can we calculate about how many avocados are coming in through per second? And you can see that this is a lot more granular and you're getting a lot more variation over time versus 5 minutes is a lot smoother. We'll just wait a second for this to load. Yeah, so now you can see that it's a lot smoother and a lot coarser. So what's actually going on under the hood here? So for this, we have data that is essentially measuring different things about the fruit, but all that matters here is we have an array where the length of the array is equal to how much fruit is coming down the line in a given second. And so with that information, we can essentially compute the throughput. So we want to sum the length of the arrays over the rows between the current row with the current date time, and then time interval over 2, because we're capturing data every 2 seconds. So for example, if 300 is our time interval, we are getting the past 150 rows, and we're calculating the sum of the amount of fruit that's coming in over 150 rows. And then we're dividing that over the time interval to calculate our actual throughput. And so that is what you get here. And I just wanted to show off one more feature. So the reason that it's so easy to integrate all these new locations is that we have a variable called location ID that is represents each different location that we have. And so if we were to select a new location, then we're able to see the throughput coming in from a site. Maybe this is across the world, which is really awesome. And so it plugs in right here in our where statement so that when you select from the dropdown, you're able to see whichever location you choose. And so that's all.
Thanks, Bailey. So in summary, Grafana is an instrumental component of our treatment operations system architecture. Without Grafana, we wouldn't be able to monitor our treatment processes around the world in real time to ensure we are delivering a high quality product. It enables collaboration across our disparate operation teams and helps them learn from each other and optimize our processes over time. So thank you for joining us. Please join us at community.grafana.com, and for Grafana's public Slack, you can see it on the screen here. Thanks again. Hey Bailey, how are you? And welcome everyone to the live stream. We're here to answer all of your questions. So please go ahead and submit any questions that you have. Thank you for attending our session today. We're excited to be here and learning about Grafana, and hope that we can also contribute and you're learning as well from us. So a couple questions have come in. First question is, can we ask you to share this link by Slack channel? So I believe all of the presentations will be posted after GrafanaCon is over. So you can come back and find the archive of not only our presentation, but all the other presentations as well. So feel free to come back and use that as a resource. All right, next question. What data lake solution are we using? Very good question. So today, our architecture is always evolving, and as we invest further in it, today, our current data lake is a custom built solution that is built on top of a very common open source database, relational database. And we host this in one of the leading platform as a service solution providers. So we are currently and planning to evaluate more commercial solutions that will help us scale as we move forward over time. Anything you want to add, Bailey, to that?
No, I think you just about covered it.
Next question here is, you mentioned that once there's internet, the edge servers would automatically push their data to the data lake. How's this managed, scheduled on the edge? Bailey, maybe you can handle this question.
Yeah. So we have a system set up that synchronizes our data from our local hubs and pulls it into the cloud. And we're assuming that for the most part there is internet, but we basically are able to upload our data that has local IDs and is centralized, and we can map them all to a more remote ID in our cloud database so that it can all live in one database together. And yeah. Brian, do you have anything to add?
Yeah, only that I wish there were reliable internet. Our edge architecture certainly enables the use case and our need for running our operations when there isn't any internet available, using a pretty sophisticated custom built solution synchronizing this data up to the cloud. Hopefully satellite internet will come someday and resolve that problem so that we don't need to rely on this architecture that we built.
I think we have one more question.
Yeah. Bailey, so how did you go about integrating the SSO solution and Grafana?
Yeah, it was actually really simple. All we had to do was take a little piece of code that was provided on Grafana's website that and threw it into our config file, which helps host our Grafana instance. And we just needed our little API key and token, and it worked seamlessly. And we also were able to set up Grafana hosted accounts for anyone that needs to view our dashboards that doesn't have access to our single sign-on. So it was really great that we were able to integrate those both seamlessly and let them work beside each other.
Yeah, this was impressive. I was super impressed with the Grafana's platform and the ability for it to not only integrate with our SSO solution very easily and seamlessly, but then also allow us to authenticate external users who are outside of our four walls and our partners who also want to gain access, and being able to provision only the data that we want them to see using Grafana's security. So I think we're up on time. Again, thank you everyone for joining us today, and we look forward to seeing you again in the future. Bye.